Hey, this is Mr. Beckstrom, and today I want to do a sample problem from section 4.1. This is on polynomial functions. So the question here is, it says construct a polynomial function f with the following characteristics. We want the zeros at -5, 1, and 5. And we want the degree of the polynomial to be 3, and we want the y-intercept to be at 50. So let's first kind of take a look at what we're trying to achieve here. So if we kind of just do a little graph here, we wanted to, the zeros are where it crosses the x-axis. So we wanted to cross here at -5. We wanted to cross here at +5. We also wanted to cross here at +1. The degree 3, that means that the highest degree of the exponents is going to be 3. And the y-intercept, we'll take a look about, that'll kind of be the last thing that we do with this problem. So here, we could get some kind of function that maybe looks like this. There's an infinite number of ways that we can draw this, and there's an infinite number of functions that fit this criteria. So the first things I want to do is I want to turn these zeros into factors. So the -5 there, we can write that as x plus 5, right? Because if we were to say x plus 5 is equal to 0, and we were to subtract 5 from both sides, we'd get x is equal to -5, giving us a 0 at -5. That means that we're also going to have an x minus 1, kind of similar. Let me go ahead and write it all in one function here. So we're also going to have an x minus 1, and then we're also going to have an x minus 5 for that 5 there, minus 5. So if I set up a function like this, y is equal to this function, this means that we're going to have a 0 at these 3 values there, at -5, +1, and +5. Now, let's look at the other 2 criteria. The next one says we want the degree to be 3. Well, that's great, because when we multiply all 3 of these factors together, the largest exponent that we're going to have for a variable is going to be x cubed. So it already fits that criteria there, so we don't need to do anything else. And we can always check that by just multiplying all the factors together, all the variables of those factors together, and that'll give us what the highest degree of variable is going to be. And the last thing it says is we want the y-intercept at 50. So let's take a look right now if we just multiply all the constants together and see what we get. So we get 5 times -1, which is going to be a -5. -5 times -5 is going to be a +25. So right now, if we were to multiply all 3 of these factors together, we'd have an x cubed starting this polynomial, and we'd end with a +25. Now we want to end with a +50, so what can we do there? I can just put a little 2 on the outside here, because then you're going to have a 2 times 5 times -1 times -5, and that will give us a constant in our polynomial of +50, and that's it. This is probably the simplest polynomial that we can build from this information here. We really have to have an intercept at some multiple of the product of our constants, and looks good. If you have any questions, let me know, and have a great day. Thanks.